Good morning. I am sure that there are colleagues here in this room who did not hear about the update, so I will update you on the ITRF 2020 update and will give some specific element regarding the IGS contribution. Before I go to the next slide, I want to acknowledge the contribution of the ITRF team, who are part of the ITRS Center. I am heading at IGM. So you have the names of the team here in the first slide. Okay, so the key points of my presentation, I will just summarize the importance of the IGS contribution to the ITRF. Of course, the three other techniques, DORIS, SLR, and VLBI, are also important. Without the integration of the four technique, we cannot do the ITRF. So I will explain the motivation why we, or the ITRS Center, decided to have regular yearly updates of the ITRF 2020 with the motivation. Some words about the specifications, and I will show you some preliminary results that is going on now. So the IGS specific contribution to the ITRF, it ensures the inter-technique link, which means that it connects the three other techniques within the ITRF combination. Just because if you take DORIS, SLR, and VLBI by pairs, you don't have enough collocation site between these pairs to construct a reliable ITRF. And this contribution of the IGS reinforces the ITRF definition in terms of origin scale orientation. It provides the most precise polar motion estimates, and the determination of the post-seismic deformation will rely on the IGS time series at sites where we have major earthquakes. And actually, the IGS contribution contributes significantly to the ITRF YY plate motion models. And we know all that the IGS gives access to the ITRF and densification of the ITRF through the IGS products. So why we do that, why we propose to do the yearly update, we will use the same strategy as for the ITRF 2020, which means we stack all the technique time series all together. So adding extended time series is easy to provide, to handle. The motivations include a number of specific points. The errors in the ITRF station coordinates are more and more amplified as they are extrapolated after the end of the ITRF input data. There are stations which are subject to equipment change, and you have discontinuities or earthquake, and these stations will no longer be used as reference frame stations to align other solutions to the ITRF. And most of the technique centers who are providing input to the ITRF, they update their own realization of the ITRF. This will increase the lifetime of the ITRF 2020 and will probably may postpone the need for a next version of the ITRF. And now, today, we can show that the scale agreement between SLR and VLBI is at the 1 millimeter level. Since more than 20 years, we are waiting for that. And the origin and scale are stabilized, as I will show you in the next slide. This will simplify the life of the users with no datum change in their applications. So here I am showing the transformation parameter, the 14 transformation parameters from ITRF 2020 to the past solution. If you focus on the origin component from ITRF 2005 up to ITRF 2020, a very simple computation, you conclude that the accuracy of the origin of the ITRF over time is, in the worst case scenario, is about 5 millimeter. And the stability is around 0.5 millimeter per year. But if you look to the ITRF 2014, then the values are within 2 millimeter actually, which means that the stabilization of the origin of the ITRF is real. Now, in terms of the scale, we have a stability within 0.4 millimeter, It is not that stability, because there is a big difference between ITRF 2014 and ITRF 2020 scale. And now if we have an agreement between SLR and VLBI, we thank the ITRS for that, because they started to estimate the range biases, which improved the scale definition with respect to VLBI. And of course, the ITRF 2000, which is old by 24 years, is just out of the picture. It is discrepant by 3 centimeters. As I said, we will use the same analysis strategy for the ITRF 2020, which means we will accumulate the full technique, the 4 technique time series altogether, adding co-motion constraint and local ties at co-location site. You have to keep in mind that we will not change the frame in terms of it is defining parameters, the origin, the scale, and the orientation. These will be the same. We will add 3 years more data and recompute everything, and we will keep that frame definition the same. So the ITRF 2020 update will be delivered using the same file format as we did for the ITRF 2020. And the technique centers actually who provided input, they did not change that much their models when they contributed to the ITRF 2020. So the analysis is still ongoing. I will focus on some results, but first of all, I want to show the map of the ITRF 20. It does not change that much compared to the ITRF 2020. And here is the network of the IGS. We have as you see, more than 3,200 discontinuities. And in fact, actually, we have more than 200 discontinuities, more than what we had in the ITRF 2020, which is normal. Now, some preliminary results using the extended data. I will start by SLR intrinsic component for the TX, TY, and TZ. TX, TY, and TZ, and the scale time series. And here we used to define the origin and the scale using the ITRF 2020 time series. We did not include the extended data in the origin and the scale definition. And if we do that, you will see very tiny, sorry, hold on, I'm going too fast. No? Okay, sorry. Yeah, the pointer is not helping. Okay, here when you use the internal constraint and when, no. I had too much coffee this morning. Okay, so the difference between this and this, it will be at the level of 1 millimeter, which demonstrates the stability of the origin of the SLR used in the ITRF computation. Now, this is for IGS contribution, and as you see, they actually, as Paul can explain that better than me, they align all things to the ITRF 2020. There is nothing to mention here except that probably there is a small offset when we started the extension, but it is tiny at a fraction of millimeter. And here for Doris, we continue to see the same behavior of these parameters with this Y excursion in the Y component. Now, you might remember that for the ITRF 2020, we did filter the VLBI sessions and the red dots that we used in the scale definition. Now, as you see for the extension, it seems like we are coming back to normal, and I am happy to see that, but it is not completely flat. So if you use the sessions that we selected for the ITRF 2020, and if you go now to include the extended data, you will change the scale by 0.34 ppb with a drift of about 0.025 ppb per year. So you will change the scale definition given by VLBI. And therefore, we decided to keep the same sessions that we selected from VLBI to contribute to the scale definition, and to say that correctly, to keep the same scale for the ITRF 2020. So I am coming to the conclusion. No major issue so far with the input data from the technique extended data. We discovered 2 weeks ago a small, tiny problem in the IGS time series. So the IGS will regenerate their contribution and we will use an updated time series. The stability of SLR origin and scale with the extension is at the level of better than 0.1 millimeter per year. And the IDS VLBI scale comes to normal, but still we need probably more data to see if it comes completely to normal as before. We expect the release to be in the summer. Well, the summer has already started. And again, there will be no change to the defining parameter of the frame and seasonal signals in origin scale orientation. What about the name? When you have a new baby, you have to go. So we propose to name it ITRF 2020 U 2023. U for update. 2023 means that we will use the full data up to the end of that year. So I hope this will not create any problem, this new name that we will give to the update. But keep in mind, we will keep the same frame in origin scale orientation. Thank you very much. Sorry for my time.